everyone, for today's lesson, we are going to learn about inverse trigonometry. Our learning targets for today are for you to be able to say, I can solve triangles using inverse trigonometric ratios. Our warm-up for today is something that is a topic that we've already talked about, and that is about solving right triangles. So what I would like you to do is please pause the video and solve this right triangle. I want you to show all of your work and round all angles to the nearest degree, if that makes sense, and all side lengths to the nearest hundredth. You will need a calculator for this lesson, so you want to make sure that that calculator has sine, cosine, and tangent capabilities. So you're going to see onto your calculator sine, cosine, and tangent. So make sure that you have that. All right, let's go ahead and pause the video, answer this question. I also want to make note really quick that we're not finding the length of little c. We're trying to find actually the length of little b. So that is one change that I want to make sure that I put in there. All right, go ahead and pause the video and then restart it once you have an answer, and we'll see how well you did. All right, so for this problem, what is really nice about it is that we already know 2 out of our 3 angles. And we also know that all of the angles of a triangle add up to 180. So I can quickly find the measure of angle B by simply taking 180 and subtracting 90 and 23 from that 180 degrees. And when I put that into my calculator, I end up getting 67 degrees. So hopefully you found that the measure of angle B is 67 degrees. Now we have little a and little b. And as a quick reminder, remember that we always label the opposite side of an angle the lowercase letter of it. So for example, the side opposite of angle A, we call little a. The side opposite of angle B, we call little b. And the side opposite of angle C, we call little c. And in this problem, we already know what little c is, but we don't know what little a and little b are. And because this is a right triangle, we always use trigonometry if we can, meaning we use SOHCAHTOA. We don't use the law of sines or the law of cosines for this particular problem. So in this problem, based on 23 degrees, which is the angle that's given to me, A is the opposite, and I know the hypotenuse. And of our trigonometric ratios of sine, cosine, and tangent, the one that uses opposite and hypotenuse is sine. So I'm going to write that the sine of 23 is equal to the opposite, which is A, divided by the hypotenuse, which is 40. Remember that sine of 23 is actually a fraction over 1, and we use cross product in order for us to solve for A. By doing that, we end up with A is equal to 40 times the sine of 23. And 40 times the sine of 23, if we were to put that into our calculator, is 15.63. And in this problem, because we're dealing with feet, our units would be FT, feet. If we did not have units, we would simply write UN to represent units. So 15.63 feet. Next, we want to find what little b is, and I'm going to go back to just working with given information. And with respect to 23 degrees, little b is the adjacent side. We are given the hypotenuse, and the trig function that uses adjacent and hypotenuse is cosine. So I'm going to write cosine of 23 degrees is equal to the adjacent, which is b, divided by the hypotenuse, which is 40. Remember that cosine of 23 is just a number, and so we make that over 1 and use cross product to find what b is. So b is equal to 40 times the cosine of 23, and when we put that into our calculator, we end up with 36.82 feet. So hopefully you found that you got these answers correct, and if you didn't, hopefully the error that you made was minor. But this is our foundation. And what's really nice about this particular warm-up problem is that all we used was SOHCAHTOA to find the side lengths. And when it came to our angle measure, we easily used the triangle sum theorem that says that all of the angles of a triangle add to 180. But So far we've talked about finding those side lengths using Pythagorean theorem and SOHCAHTOA. But what happens if you didn't have enough information to find an angle? If you know the sine, cosine, or tangent ratio of an acute angle of a right triangle, then we can find its measure. And to do this, we use a thing called inverse trig ratios on our calculator. So we've talked about the word inverse before. It is an operation that undoes another operation. So for example, addition and subtraction, they undo each other. They are inverse operations. Squares and square roots, they are inverse operations. But how would you undo sine, cosine, and tangent? Well, sine, cosine, and tangent are also operations, and they have their own inverse operation that undoes it. So as I recall, to solve a right triangle, just like what we did up here, we find all of its angle measures and all of its side lengths. Inverse trigonometry is used to find missing angle measures. So it goes like this. The inverse tangent. If you know that the tangent of A is equal to X, then the tangent inverse, remember that negative first power represents the word inverse, and this expression is read as tangent to the negative first power of X is read as the inverse tangent of X. And so that negative first power isn't a power, it represents the word inverse. So a lot of kids get confused by this. So what I'm going to do is show you something that we typically don't write in mathematics, but if you're a visual learner, this might help you. So let's say that we have the tangent of angle A is equal to X, and I'm going to leave a little bit of space in between here. How would you get A alone? Well, you can't divide by the word tangent. It's like dividing by a plus sign. That's not what we do in mathematics. So we use an inverse operation. Just like addition gets rid of subtraction and squares get rid of square roots and exponentials get rid of logs, tangent inverse eliminates the tangent. So what we do to one side, we do to the other. So we're going to take the tangent inverse of both sides. And what ends up happening is that the tangent inverse and tangents cancel away, leaving us just with the measure of angle A. So the measure of angle A will be the tangent inverse of X. So a lot of times in mathematics, we skip this step of taking tangent inverse of both sides, which this type of operation always has to take place in front because we always take the sine, cosine, or tangent of something, so it has to go in front. But a lot of times we skip this step of doing one thing to one side and one thing to another, and we just go straight to what our answer is. If you're, like I said, if you're a visual learner and you need to show this stuff, there's nothing wrong with that, especially while we are learning for the first time. Next, if we have the sine of A is equal to y, and I want to figure out what the measure of angle A is, what I can do is I can take the sine inverse of both sides. And what happens is that the sine inverse and sine will cancel away, leaving us with just the measure of angle A. So the measure of angle A will equal the sine inverse of y. The same is true if we had the cosine of angle A is equal to z. If I want to figure out what the measure of angle A is, I'm going to put parentheses around both sides and take the cosine inverse of both sides. What happens there, once again, is that the cosine inverse and cosine cancel away, leaving us with the measure of angle A is equal to the cosine inverse of z. Now, what's really cool is that our calculators, regardless of whatever calculator you are working with, if you zoom really, really close, and I know that this is really blurry, so just give it a minute to kind of focus. Oh, goodness. Hold on. There we go. So if you look at my calculator, thank you for your patience there. What you'll see is that there is sine inverse above the sine button, cosine inverse, and tangent inverse. just above these buttons. And the way to access those operations is you have to press your second button or your shift, and then that'll bring you to the inverse functions. So we're going to go ahead and do a little bit of practice. In example number 1, it's asking you to find the measure of angle A and the measure of angle B, letting you know that they are acute angles of a right triangle. So we're going to use our calculator to approximate these values to the nearest hundredth of a degree. Most of the time in our class, we round to the nearest whole degree, but for this example, we're going to round to the nearest hundredth of a degree. So we have here the sine of angle A is equal to 0.76. If you want to show on both sides that you're taking the sine inverse, you're welcome to do that. If you don't want to and you want to just go straight to writing the measure of angle A is equal to the sine inverse of 0.76, you can do that. Now remember that sine, cosine, and tangent is equal to a ratio, sine being opposite over hypotenuse, cosine adjacent over hypotenuse, and tangents opposite over adjacent. For those ratios, they simplify to equaling a decimal. And now we're going to take that decimal and figure out what angle gave us that 0.76. So in my calculator, I'm going to press second, and I'm going to go down to sine. So second sine, so now I see sine inverse of 0.76. And I'm going to close my parentheses, and I end up with 49.46 degrees. And that is the measure of angle A. 49.46 degrees. For letter B, if you want to skip taking the cosine inverse of both sides and just go straight to the measure of angle B is equal to the cosine inverse of 0.17, that's what we do in all other mathematics courses. And when you put that into, I'm sorry, this is angle B, excuse me. And when you put this into your calculator, you're going to find that the measure of angle B is equal to 80.21 degrees. And if you were to try letter C on your own, which make sure that you can do that, if that means you need to pause the video to make sure that you know how to use your calculator, it's important that you're able to do that. So in this problem, we would have that the measure of angle A is equal to the tangent inverse of 0.8. And when we put that into our calculator, we end up with the measure of angle A is equal to 38.65 degrees. All right, so now what we're going to do is we're going to solve a different type of right triangle. And in this problem, I'm not giving you any angles. I'm only giving you 2 side lengths. So the directions are just like our warm-up. I want you to show all work. We're going to round our angles to the nearest degree and all side lengths to the nearest hundredth. But this time around, the thing that would probably be the easiest to find would be our side length, but if it's helpful for you just to go in order of the lines, let's just go in order of the lines. The first thing that we need to identify is the measure of angle A. So I'm going to make angle A my focus angle, and with respect to angle A, 16 is the opposite and 20 is the adjacent. So I know that the tangent of angle A, if I knew what the measure of angle A was, it would be equal to 16 over 20. But I don't know what the measure of angle A is. So I can find that using inverse. I know that the measure of angle A will be equal to the tangent inverse of 16 over 20. So now I'm going to put this into my calculator. Tangent inverse of 16 divided by 20, that's equal to 38.66 degrees. And since we want the nearest degree, that's going to be about 39 degrees. So I'm going to write 39 degrees on this line. The next thing we need to do is we need to find the measure of angle C. So there are 2 approaches, and I want to make sure that I talk about both approaches for finding the measure of angle C. So I'm going to write that down. There are 2 ways to find the measure of angle C. The first way that you can find the measure of angle C is to use this 39 degrees and say that the measure of angle C is equal to 180 minus 90 minus 39. And when you put this into your calculator, you'll find that this is supposed to be C, excuse me. you'll find that the measure of angle C is equal to 51 degrees. That's one approach. Another approach is for you to use tangents. So with respect to angle C, 20 is no longer the adjacent, it would be the opposite. And with respect to 16, or 16 with respect to angle C would be the adjacent. So we would work with tangent. The tangent of angle C would be equal to the opposite, which is 20, divided by the adjacent, which is 16. And we would work with tangent inverse again. So the measure of angle C would be equal to the tangent inverse of 20 over 16. And when you put that into your calculator, you end up with 51.34, which would round to 51 degrees. Both approaches would end up getting you 51 degrees. Now, here's a truth. One requires you to use information that was obtained. And if you had made an error back here at 39 degrees, that means that anything that came after it where you used that 39 degrees would also be considered an error. In my class, I grade holistically. So if you make an error in like step 1 and it leads to all of the other answers being errors as well, as long as your steps are correct, I will grade holistically, meaning that I'll only ding you on your very first error, and then everything else you can receive full points for as long as it's correct. Because obviously you were dependent on what came before. So I just wanted to at least put that out there for my class. But that last thing that we need to find is little b. And remember that we always label with the opposite side and taking an angle, and the side opposite of that angle will have the same letter, but just lowercase. So little b is the hypotenuse. And in this problem, it's a right triangle. And whenever you try to find missing side lengths of a right triangle where you know 2 of those side lengths, we typically use the Pythagorean theorem. Could you use SOHCAHTOA? Of course you can, but that once again goes back to what I was saying before, where you're working with obtained information. And if you made an error, then you're using that error to find other missing lengths or missing pieces. So personally, I would recommend using SOHCAHTOA. So I'm going to write 16 squared plus 20 squared is equal to b squared. So that is 256 plus 400 is equal to b squared. So that's 656 is equal to b squared. We're going to take the square root of both sides, and when we put that into our calculator, we end up finding that b is equal to 25.61. In this problem, we do not know what the units are, so the units that we write down is simply 25.61 units. All right, let's go ahead and do a few more problems where we're trying to find missing angle measures. So it says in example number 3, you are building a track for a model train. You want the track incline from the first level to the second level to be 4 inches higher in 96 inches. So in 96 inches, you want this incline to rise 4 inches. Is the angle of elevation less than 3 degrees? So let's go ahead and write down what we know with respect to angle X. So 4 inches is the opposite, and 96 is the adjacent, and the trig ratio or the trig function that uses opposite and adjacent is tangent. So I'm going to write the tangent of X is equal to our opposite, which is 4, divided by the adjacent, which is 96. So I'm going to take the tangent inverse of 4 over 96. And when I put that into my calculator, I find that X is equal to 2.39 degrees. So in terms of our question, is the angle of elevation less than 3 degrees? The answer is yes. The angle of elevation is less than 3 degrees. You wouldn't even round to 3 degrees, so that's kind of cool. If you would like, please go ahead and try example number 4. And this is supposed to be example number 5. Please go ahead and try example number 5. on your own. Please go ahead and pause the video, and when you are ready, go ahead and restart the video, and we will see how well you did. All right, in example number 4, it says a driveway that is 25 meters long is built on an incline. It has risen a distance of 4 meters by the time it reaches from one end to the other. What is the angle of elevation of the driveway? So in this problem, 4 meters is the opposite of our angle of elevation. 25 meters is across from the right angle, so that's the hypotenuse. In the trig function that uses opposite and hypotenuse, that's sine. So I'm going to write that the sine, and I don't know what this is, so I'm going to call it x degrees, is equal to the opposite, which is 4, divided by the hypotenuse, which is 25. So to find x, I'm going to use inverse. So I'm going to write the sine inverse of 4 over 25, and I'm going to put this into my calculator. And when I do that, I end up with 9.21 degrees, which is approximately 9 degrees if we were to round to the nearest whole number. For number 5, this one was a little bit different, and there are many approaches for this problem, but this is how I view this problem. First of all, I'm going to drop a perpendicular so that I can see my right triangle. And it says each step of a stairway rises 18 centimeters. So I'm going to mark that each of these steps are 18 centimeters. The tread width, which is of each step, is 32 centimeters. So here's 32 centimeters, 32 centimeters, and 32 centimeters. What angle, theta, does the stairway make with the floor? So with respect to the height of the stairs, what I know is that each of these pieces are parallel to the height. And one piece is going to be 18 centimeters. Then another piece is going to be 18 centimeters. And then the final piece is 18 centimeters. 18 plus 18 plus 18, that is 54 centimeters. And we're going to do the same thing with respect to the tread. The tread is parallel with the floor. So one piece is 32 centimeters, then another piece is 32 centimeters, and then another piece is 32 centimeters, and 32 plus 32 plus 32 is 96 centimeters. And 54 centimeters with respect to theta is the opposite. 96 is the adjacent. Opposite and adjacent means that we're going to be working with tangent. So I'm going to write that the tangent of theta is equal to the opposite, which is 54, divided by the adjacent, which is 96. So that means that theta is equal to the tangent inverse of 54 divided by 96. And when I put that into my calculator, I end up getting about 29 degrees. So now this one's missing a name, so insert any girl's name. I guess I'll pick my own, Mrs. Olivero. Mrs. Olivero is hang gliding at an altitude of 300 feet. So Mrs. Olivero hang gliding at an altitude of 300 feet is over a spot that is 2,220 feet from an area of soft grass where she would like to land. Draw and label a picture, and at what angle of depression should she see the grass? All right, so it's always helpful to at least draw a picture of what's going on. So we're going to pretend that this is a picture of me hang gliding. So this is me hang gliding. Cool. And I see on the ground this patch of beautifully soft grass. And I'm looking at it because this is where I would like to land. And it says it looks like I'm hang gliding at an altitude of 300 feet. So what I'm going to do is I'm going to draw a picture of an angle of depression, because angle of depression is created with this line that is parallel with the ground. It's called like if I was looking straight, there's this invisible line that's parallel with the ground. And it's this angle that's created by looking down. I don't know what it is, so I'm going to call it x degrees. I am 300 feet in the air. And I am over a spot that is 2,250 feet from the soft grass area. So this is where it gets kind of confusing. Is this distance horizontal distance, or is it the hypotenuse distance? Now, if you think about it, if I am a certain feet away, would my certain feet away be me floating above it or going directly to it if I want to land? Well, it's going directly to it. That is 2,250 feet is actually the hypotenuse in this case. So in order for me to find x, 300 is the opposite. 2,250 is the hypotenuse since it's across from the right angle. So that means I'm going to be working with sine. So the sine of x is equal to the opposite, which is 300, divided by the hypotenuse, which is 2,250. So I'll be working with inverse sine. So I'll say that x is equal to the sine inverse of 300 divided by 2,250. And when I put that into my calculator, I end up with 7.66 degrees, which is approximately 8 degrees if we're talking about the nearest whole measure. We have one more example, and then we are done with this lesson. In example number 7, we want to simply solve the triangle. Same exact rules will apply here. In this problem, it is not a right triangle, unlike the other triangles that we've worked with. So how do you solve a right triangle? Well, that goes back to our previous lessons that we've already had. In order for us to solve a right triangle, in order for us to solve any type of triangle, we're either going to work with this thing called the law of sines or the law of cosines. So it just depends on the information that's given to us. In this problem, I'm going to label 43 as little b and 19 as little a, according to our angles in this picture. And what's nice about this problem is that I am given two of a kind, an angle B and a side B. And if you are ever given two of a kind, that tells you that you're going to be working with the law of sines. So in this problem, we need to find angle A, angle C, and little c. So I'm going to mark that up. And I'll go in order of our list that we have here. And I'll start by identifying what the measure of angle A is. So I'm going to use the proportion of A divided by the sine of angle A equals B divided by the sine of angle B. Little a, I know that that is 19. I don't know what the sine of angle A is, so I'm going to write that down. B is 43, and I'm going to divide that by the sine of 123. So now what I need to do is I need to use cross product. When I do that, I end up with 43 times the sine of angle A equals 19 times the sine of 123. So now I need to get the sine of angle A alone so that I can eventually work with inverse. So that means I'm going to divide both sides by 43. When I do that, I'm left with the sine of angle A is equal to 19 times the sine of 123 divided by 43. So now I need to find what the measure of angle A is, which means I need to undo sine. To undo sine means to take the sine inverse of the other side. So I'm going to write that the measure of angle A is equal to the sine inverse of this whole fraction, 19 times the sine of 123 all over 43. And this whole statement is something that I'm going to enter into my calculator. So I'm going to put into my calculator sine inverse of 19 times the sine, regular sine, so not sine inverse. So that's something that a lot of kids mess up on. We're only using sine inverse once. The other piece is normal sine of 123 degrees. So always make sure your calculator's in degree mode. That's really important. I know that my calculator's in degree mode because it says so up here. You can always check by clicking on the mode button if you're working with a graphing calculator and verifying that it's in degree mode. So this is 19 times the sine of 123 divided by 43. And now I'm going to close the parentheses to say that I'm done taking the sine in, or what I'm finished putting in what I'm going to take the sine inverse of. So I'm going to write enter, and I end up with 21.75 degrees, which is about 22 degrees. Rounding it to the nearest whole number. So now, since I'm dependent on finding the measure of angle C, and I can't use SOHCAHTOA, I'm just going to work with the fact that all of the angles add up to 180. So I'm going to say that the measure of angle C is equal to 180 minus 123 minus what we found the measure of angle A to be, which is 22. And when we put that into our calculator, we end up finding that the measure of angle C is 35 degrees. So now that I know that the measure of angle C is 35 degrees, I can now find little c using, once again, the law of sines. Only this time I'm going to be working with c divided by the sine of c equals, going back to working with the pieces that were given to me, I'm going to work with little b divided by the sine of angle b. So little c divided by the sine of 35 is equal to little b, which is 43, divided by the sine of 123. And I'm going to use cross products so that I have c times the sine of 123 equals 43 times the sine of 35. I need to get c alone, so I'm going to divide both sides by the sine of 123. When I do that, I am left with c equals this whole fraction right here. And I'm going to put it directly into my calculator. So please make sure that you practice putting these values into your calculator. I'm going to go 43 times the sine of 35, and I'm going to divide that value by the sine of 123. Always make sure that you're closing your parentheses of whatever you're taking the sine or cosine of, depending on what type of a formula that you're talking about. And in this problem, I end up with 29.41 units. And that is the end of today's lesson. If you have any questions over anything that I talked about, please feel free to email me. Otherwise, I hope you have a wonderful day.